Data does not lie, but people do. Or at least they sometimes will twist the truth. Have you ever believed a statistic only to realize later that it was the way the person was using it that misled you? Today, we're going to talk about how people can very easily trick you into thinking that X has caused Y, when in reality, X has had absolutely nothing to do with it. My name is Matthew Torquia, and I've worked with data for almost 5 years now during my master's degree and in the airline industry, and I've seen how numbers can get twisted. I'm here to help you spot these traps and make smarter decisions. So this thing that I want to teach you about today is very commonly known as correlation does not equal causation. And I want to talk about this in 3 different sections. One, I want us to understand truly what is the difference between correlation and causation. The second thing is, why is it so dangerous to confuse the two? And third is, how could we actually test for causation if we need to? And I'll show you 3 common ways to do that. So what's the difference between correlation and causation? Correlation is when you have 2 events and when one of them moves a certain way, the other one moves as well. For example, the more money you have, there's a good chance you have more years of schooling. There's a strong correlation between the two. Whereas causation is saying that when event A happens, it causes B to happen.
All right, let's put this into an example. Imagine it's a really hot day. What do people really like on a hot day? Well, ice cream. So the sun basically is gonna cause ice cream sales to go up. Another thing it could do is cause sunburn rates to go up. Those are 2 causal things. The correlation comes in when you start seeing that as ice cream sales go up, sunburn rates are going up also. But that doesn't mean that ice cream is what's causing sunburns. As we showed here, it's really because of the sun.
So it doesn't really seem like the differences are that big between the two, but it can have massive impacts if you assume that correlation and causation are the same. For example, let's say you have a new product that you want to put to market, but you're not sure what to price it at. One way you could go about this is to do some type of experiment. So on month 1, you charge $100. On month 2, you're going to increment it to $110, and then month 3, $120, and so on for the rest of the year. And the reason you're doing this is you want to see during what month or what price did you get the most revenue. In this example, let's imagine that every single month, as you're increasing the price, the revenue is also trending in the same direction. This is something we would say is a strong correlation. You see that as the price increases, so does the revenue. What would be misleading here is to assume that the reason the revenue is going up is because you're having a higher price. That statement there, that's a causal statement. You're trying to find the reason as to why you're generating higher revenue. While it looks like higher price is causing higher revenue, in reality, maybe the reason this is happening is because, well, your product has been out to market for a longer period. Maybe more people have heard about it. The marketing campaigns have gotten better. So this is an example where you see a very strong correlation, but it doesn't necessarily mean that there's a causal link between the price and the revenue. The reason this is dangerous is because if you're assuming that there is a causal link here, you might think that, hey, we should just continue charging a higher price. It's clear that a higher price is just generating more revenue. But that might not be the case. There might be money left on the table here because maybe you might be charging too much. So how can we actually figure out if there is a causal link between 2 different variables? One of the ways we can do that is by running an A/B test. So in the example of the ski equipment, what we could do is every single customer that comes to our shop, let's say it's an e-commerce shop, there's a 50-50 chance that they're gonna get price A, which is let's say $100, or price B, $200. And then you could actually see over the next, let's say 1 month, the people that were shown the $100 item, how many of them actually purchased and how much revenue did we get from those people? And compared to the other group, maybe you'll find that the group that had the $100 price, they were 3 times more likely to buy, whereas the others were 3 times less likely. In that case, because you're charging $100, but 3 times more likely to purchase, you're going to be getting more revenue from that price versus the $200 price. Sometimes though, A/B tests are not really possible to do. Let's say you have a physical store. You can't just randomly say, hey, you're going to get a $100 price and you're going to get a $200 price. That just doesn't work. Sometimes you need to have one price. So this example wouldn't work. This wouldn't work. What you could maybe do for the ski example is, let's say you have multiple stores. You could charge a certain price at one store and another price at another. The issue there is that there could just be different behaviors between people that go to one store versus the other. Maybe one of them is in a better neighborhood than the other. So it's a bit more difficult to actually find a causal link. Another thing we could do is looking at using the linear regression. Let's take another example. Let's say we want to understand how much does every year of school actually increase your total income once you start working. What you could do is just look at, okay, what's the average income of people that have 10 years of schooling, and then 11 years of schooling, and 12 and 13, all the way to 17 or more. That's one way to do it. But what that's missing is the fact that it's not necessarily true that the reason you're getting more income is because of the more years of schooling. It could just be that as you get more years of schooling, there's a higher chance that you're coming from a more wealthy or privileged background. And that is actually what's causing the higher income. So again, it's not that the school is necessarily bringing in, letting you get more revenue. It's the fact that people who go to school for longer come from wealthy backgrounds, and it's the wealthy background that helps you get higher income. Again, that's not necessarily true. What studies have actually found is that more school typically does increase your revenue. There's a causal link there up to a certain level. It was at the PhD level where it starts to either plateau, but a linear regression will help you take into account all of these other factors that could be impacting your income in this situation and let you actually find what is the impact of that specific thing that you were curious about. So these were 2 common ways of being able to test for causality, and it's super helpful because there are many times where you really do want to know when something causes something else. It's great to know that there's a correlation between things, but it's even more powerful when you know that, hey, if you do this, this thing's probably going to happen. That's a really powerful statement to make, and it's something that's a lot more difficult in practice. If you like this video, feel free to check out this other video I made about why averages can be one of the most misleading things you do to your data. Thanks for watching.